We start out as one, but we end up with like 35 trillion. Remember, that number keeps going up. So we go 13 to 35 trillion cells. All those animals you saw on the video yesterday, way more than even what we got here. Okay, just for you guys to know, we started as one cell. Remember, that cell will start to grow, and remember, even that cell is under rules. And it gets too big, it's got to divide, or else it's going to die. It's going to starve to death. All cells do that. Once they get too big, they divide. Then now we'll get big, and they'll divide. We're doing that till the day we die. Okay. Now 4 levels of cell and organization. You got to know it. It's easy. Now think about it. Anything we've talked about so far, it's not really that difficult. It's just certain things, the big words, or you got to think you got to memorize this or that. But it's easy. So like this is easy too. At the most basic level, we're a cell. Okay? That's the first level, we're a cell. What that means is that if you go down just to the cell is the smallest part of a living animal or a plant or anything that's alive that's still, it's alive. Because it needs nourishment, it needs water, it's got to get rid of waste, it reproduces. So it's the smallest part of a living thing that's actually alive. Now that cell you see over there, that's a cardiac cell. Okay, so there's only one purpose that cell is around. Of the 35 trillion cells in our body, there's 256 different types. Its job is to contract. So once it's formed as we're even in the womb, it's there until the day you die. You know your heart cells can't repair, right? So if you hurt your heart, it's a permanent damage. This cell, if it gets injured, it dies. People with heart attacks, that's what makes heart attacks so deadly. It's not like your skin where you get a cut and it heals. You can't cut your heart, you can't bruise your heart without some damage. Okay? And so that's a cell, first level. Now if you go up, a little more complicated. And I don't mean complicated, it's hard to remember. It just means the organization gets more complicated. The second level is a tissue. Not the kind you blow your nose with. Okay, when you think of tissue, and I always thought this, don't you think of like skin and muscle and things like that? But tissue can be blood tissue. So if you cut yourself and the blood drips out of your nose or you cut, and it splatters on the floor, you don't think of that as tissue. But really, red blood cells, they're all together. They're all doing the same job, period. They're a tissue. Your skin cells, they're all there. They're protecting you. They're a barrier from the outside to keeping the outside from getting in. And then your heart, there it is. That's what one of those, when you put them all together, that's heart tissue. This is tissue. You could do liver tissue. You get the idea. But they got to be made of similar cells. So it's got to be a sample with nothing but heart cells or a sample with liver cells or kidney cells. That's a tissue. Okay, next one. Organ. Let me know if I go too fast. An organ. And not the kind that you play. An organ, like your heart, your liver, kidneys, lungs. Right here's the organ, the heart. Check this out. Many groups of tissue that work together. Well, if you look at the heart, remember the heart's about, you make a fist, it's about the size of your fist, and you place it just like you're putting your hand over your heart, but you make a fist. That's where it's at. It's got fat tissue. It's got blood cells, which are connective tissue. It's got muscle tissue. This one you can't see, but there's nerve tissue in there too. So there's like at least 4, and probably more in there. And they all work together. That fat tissue, the nerve tissue, muscle, they all work together. I think it was the Children's Museum in Chicago. They have a science and industry. I don't know if that's still here. The display they had. I remember going there. I was 23, 24, and they had a display that says, "Are you stronger than the heart?" So I'm like, "Oh, I'll try it." Right? Macho. Get in there, and you squeeze the handle, and it shoots red liquid up that's supposed to be blood, and it just, you see how strong you are compared to the heart. And so I got in there, and I was like, I squeezed it, and it went about a foot, and I'm like, no way. And so I got in there, and no matter how hard I squeezed, it would only go about a foot. Some people would get in there, it wouldn't go very much farther. Some people would go, and then you press the button, and it shows you. It shoots straight up. The heart would squeeze it, and it shoots straight up 30 feet. And think of it, that thing is beaten 3 billion times in your lifetime, and it doesn't stop. So it was beaten before you were born, and once you're dead, that's it. So if you live to be like that lady we saw in the movie that was 100 and what, 12?
Yeah.
That's a lot of beating heart there. But that's the third level. See, it's getting more complicated.
She must have had the strongest heart in the world.
Somebody was saying how, think about a racehorse's heart. It's going to be like huge, and that thing is like in the best shape of any animal on the planet, or a cheetah. Think of those that are really good shape. Those hearts are going to be strong. Okay, here's the last one. This is the highest, I can't think of the word now, most complicated, but now organ system. It's a group of organs that work together. See, now we're talking organs. We're not talking tissue. We're not talking cells. We're talking organs. If we were to go out and run, you guys ever do a suicide in basketball practice? You guys know what suicides are? Where you go from the baseline, you go to free throw, back, half, center court. You do that. And if we would do one suicide as fast as we could, our heart would instantly have to go faster, right? But what you don't realize is that your heart and your lungs are connected. You ever think about that? Your heart and lungs are connected. If your heart beats faster, your lungs breathe faster. They take in more. And I know this because when I was a welder in Chicago, I got electrocuted, and I took 400 volts here to my heart, and my heart started racing because I threw off all the electrical activity. It was doing 250 beats a minute. Now I wasn't running, I wasn't walking, I was just nice and easy working, and I'm sitting there in the chair waiting for the ambulance to come. Heart rate 250. Guess what my breathing was? I couldn't hardly talk. It was amazing. That day I learned. I was like, wow, they're connected. It was like, they're like, are you okay? I couldn't hardly talk. And when they came in, they gave me a shot of something, and I was like, whoa, this is good stuff. And so it's connected, so they all work together. Digestive system, it works together. That wouldn't have done it. That wouldn't have done it. Okay? So those are your four levels of how we're organized. Now, remember, we all start out as the one cell. There it is. That's kind of an artist rendition of what it looks like. That's a stem cell. Now, in the lab, we know we can do this. We could take a stem cell, we could put it in a liquid of whatever, a certain liquid, give it a bath in it, and then maybe give it a jolt of electricity, maybe raise the temperature or lower the temperature, and we can make it turn into most any cell we want. They figured that out. But the thing is we can't make one turn into a bunch, say like make a new heart. But maybe by the time you guys are my age, they will be able to take like a stem cell from you and remake you a heart.
They're going to steal my cells?
Yeah, well, I think it would be worth it. If you got a new heart, man, that bone is really good.
That's probably mine.
Okay, so any questions? Anybody still need that? I believe stem cell is going to be a question.
Miss Hagee's outside.
Okay, I'm going to stop it here.